This video is made in collaboration with Beckhoff. Beckhoff has announced PLC++. Initially there was a big storm in the automation world, and once the storm calmed down, left were many questions of what this actually is. In this video, I'll try to explain why PLC++ was created, what it is, and what it's not. As of today, Beckhoff are using codices to get support of managing the IEC 61131-3 languages. Beckhoff takes this SDK and integrates it into Microsoft Visual Studio, which gives them things like a code editor, library management, and a compiler for everything related to the IEC languages. Then Beckhoff creates pretty much everything else you expect from an automation platform, squeezes it into Microsoft Visual Studio, and call it TwinCAT 3. Let's talk a little bit about the codices integration and the problems that the current solution has. In the current PLC solution, all the source code is stored with an XML markup that makes it hard to work with when using a version control system such as Git. The text marked in yellow is the actual source code, the thing that you're actually interested in. Everything else is markup. When working with version control, this causes an unnecessary cognitive load on the developer when doing diffs, and also causes unnecessary conflicts in the version control system. Further, because the codices software is a closed box and not developed by Beckhoff, they have no possibilities to make optimizations to it. Whatever interpretation of the IEC languages is made by codices, Beckhoff has to follow along, and it's very hard for them to make any necessary adjustments or additions, which leads me to the next point. Beckhoff are handcuffed to whatever is provided by codices. This can make something as simple as getting a proper dark mode in the online view of an application a tricky task. Historically, the dependency might have made sense and probably to some point still makes sense, but Beckhoff and TwinCAT have grown enormously over the last years, and the user base just keeps growing and growing. The next point I want to stress is that the current solution does not allow for a command line interface. Every time you want to do something like building a project, running tests, or doing a static code analysis, you have to go through a full instance of Visual Studio, which can take several minutes to fire up. Now there is this thing Beckhoff provides called the TwinCAT automation interface, providing some form of semi-CLI. However, using the automation interface is, to say at least, frustrating. It requires a full instance of Visual Studio to be fired up just to do a simple compilation, which makes hundreds of build pipelines around the world cry every day. This non-existence of a proper CLI might work for the average PLC programmer, but whenever you want to automate something like making builds, running tests, building and managing libraries, or deploying configurations, waiting 5 minutes at every commit just doesn't cut it in 2025. Codices is in no way a bad product, quite the opposite. What they're doing is amazing. Both the development and runtime are very good and successful products. They're used by many different PLC brands and manufacturers, which of a few are Eaton, Lense, Vago, Opto22, Festo, Schneider, Bosch, and many more. Using codices does, however, put limitations on what the vendors can do, so it's a trade-off between this and the option of writing the software tooling yourself. So how does PLC++ come into this picture? Currently, everything you've done so far is what Beckhoff calls the PLC engineering, and this is the one that is based on codices. I'll refer to this as simply the PLC engineering. What Beckhoff have done is to create a completely new editor and compiler for the IEC languages, which is 100% their own and which is not based on codices at all. Note that this is a pure IEC 61131-3 compiler and not a C++ compiler, as some of the initial guesses suggested. It's 100% purely an editor and compiler for the IEC languages, in other words, structured text, function block diagrams, ladder, and sequential function charts. You'll still be able to use the conventional codices compiler and editor in parallel with the new PLC++, and you can even use them at the same time, as I will show in the live demo. Alright, but what does this mean to me? While Beckhoff are at it, they're targeting the new compiler for the 4th edition of the IEC standard, which is to be released sometime in 2025. This is in contrast with the current codices-based compiler, which is based on the 3rd edition. The newer edition has a few handy features, which will be covered in a separate video. Beckhoff are also providing a completely new runtime for PLC++, which in combination with the new compiler promises up to 1.5 times faster execution times, which means that you'll be able to run even more complicated tasks without having to upgrade your hardware. All source code is now plain text. This improvement will make it considerably easier to work with the version control system. The improvements are not only made for structured text, but also for the graphical programming languages. Finally, and I literally mean finally, the new PLC++ gives access to a command line interface, meaning that it's not necessary to go through the TwinCAT automation interface and a full-blown instance of Visual Studio if you, for example, want to compile your project. With PLC++, Beckhoff has full control of the integration. This means that they're not limited by the functionality of the codices editor, and they can thus add new features as they see fit or as their customers' requests. I'll show a few of these in the live demo. And there is just a lot more that goes into this. Too much for a short introduction. Alright, I hear you say, enough talk. Let's take a look at PLC++. Hey everyone, I'm gonna show you a little bit of a live demonstration of PLC++. Beckhoff have been very generous and given me an early access to the beta, and I wanna make it clear here that this is an beta, so I'm expecting us to find some bugs and quirks here, but I thought we're gonna look together into some of the features that are available with the new PLC++ environment. So what I've created is a completely new project here. I've put in it under version control because I think that's going to be relevant when we talk about text-based storage later. And first I want to show you that the new PLC++ is available by adding a new item here to PLC. And there's a new type of project. So the old classical PLC projects are available here in the PLC default PLC templates. So yeah, this is what I call the classical now, which is the codices-based PLC projects. The new ones are available here under PLC++ templates. So I'm going to call this PLC++. And as you can see, a new type of object is created here that is not available today. So PLC++ is not a completely new development environment, which I speculated in the beginning that it might be something that's based on VS Code. Is just another node here available in the traditional Visual Studio based development environment from Beckhoff. So what does the PLC++ node look like? If you go in here, you still have the instance like you have in the traditional PLC, the classical PLC. That is, if you compile something with in and out variables, that's going to pop up here, but everything else is basically different. So first of all, we have a different library manager. So the old, if I can use the word old, the classical library manager that Beckhoff have been using is the one that is based on codices. So the libraries that were created in the classical one were compatible with the codices format of libraries. Beckhoff here, however, have developed a completely new library manager. And what this means is that Beckhoff, they had to convert all their current codices-based libraries. When I say codices-based, I'm referring to the library format from the old format, so the codices one, to the new one. So that's something, if you go here to libraries, library repository, we're gonna see that all of the Beckhoff, well, not all, but most of the Beckhoff libraries are available here now in the new format. I'm not gonna focus too much about the library manager for this time. There's gonna be a separate video in the future. What we're gonna focus on here instead is everything else here. So first of all, we have the configuration here. So the configuration gives us a possibility with a text-based file to configure the task and the real-time properties, so what the cycle time should be like. This is directly linked and managed also by the real-time properties here. So whatever settings you do here are automatically mapped over to the real-time part here. What I like with this one, with this configuration, is of course that this is text-based, which means that we can version control that. And I like that idea with the, and this is generally everything here for PLC++. I should mention that everything now is more based on pure text-based format, so it's much easier to version control and being able to go back and forth between, for all the benefits that version control obviously gives you. That's one thing. So if you look here at the main program, this looks and feels very much like the traditional classical PLC++, but the magic is actually a little bit behind the scenes. So what I'm gonna do now is that I'm gonna show you how this looks like from the perspective of looking at it in an editor that's not a Visual Studio. So in the classical PLC file format, everything was stored with this absurd and annoying XML format. Here, everything is stored in pure and clean text. So if I'm just gonna add something like a counter, and I'll add it here. Oops. And we go and look at this application, how it looks like. So I have prepared Visual Studio Code here, so we can look at the files. And we go to TwinCAT PLC++. So here I have the repository open. And we look at this main file now. We actually see this is pure text. You see, there's no XML markup, there's nothing. And this is, of course, a fantastic thing because I spend so much time today and have been doing it for a very long time. And okay, not just me, all the other 20,000 plus TwinCAT developers that hopefully are doing version control. When they commit this, you automatically have to think about all the XML and, it just messes up your version control. This is immensely much easier to manage. And there's no reason for PLC code not to be like this. There's no disadvantage whatsoever to have it this way and just skip the XML altogether. So this is fantastic. This thing only in itself makes PLC++ a big deal for me already. So I love this. Fantastic. I'm very happy about this. And this also means, of course, that, making diffs and things using it is going to be easier. So for example, if I make a commit here, so I'm just going to make a commit using VS Code, initial commit or test commit. I commit it. And I go here and make some additional changes and blah, blah. Int, save it. We go to VS Code, or we can use, of course, the team manager here in Visual Studio directly. I like to use VS Code. This is personal preference. Everyone has their own taste. If we go to changes here now, this is immensely much easier to look at and make diffs when it's pure text. I don't think I need to convince you anymore of how good this is, so I'm gonna leave it here. I should also mention that for people that are using the graphical programming languages, Beckhoff have also made a better format for storage. So if you make something like a ladder diagram, the way Beckhoff stored the source code now is tremendously much easier to look into than it was when it was based in the old codices. If you would make the equivalent ladder diagram in codices. So the benefits are not only for people using structured text. I'm not going to show that here, however, because I'm not a ladder diagram developer. I don't use graphical programming languages. That's something I don't use graphical programming languages. So how does it look like actually running this now? This is a virtual machine. I'm not running this on a real PLC, so I have done some core isolation here. I'm going to run this on an isolated core. You could, of course, use the user mode runtime, introducing 4026 as well as an option. So I'm going to just run this application. And one new thing here is that the toolbar for logging in, logging out, and doing online changes and everything is replaced with a new one. So, well, it's not replaced. You can still use the old one for the classical PLC development, but there is a new one for the PLC++. So Beckhoff have developed their own one, which is available here in TwinCAT PLC++. It is, let's see here. Oh, it's hiding there. Let's see if we can pull it over. I'm gonna put it there. Then it basically looks and feels the same way like the classical one. So this one over here, we can do an login. And sorry, I forgot to do an activate configuration. I'm gonna do an activate configuration of the application. Restart TwinCAT. We have login, and here we go. So there's a new toolbar here. There you can log in and log out. What Beckhoff have done differently here, however, is that they have separated the online change. So instead of logging in and getting the question of whether you want to do an online change, you can do it in advance, so to speak. So you can log in without doing an online change, or you can do explicitly say that I want to do an online change. So to show this here, let's add something else. Let's just add a bool here. And we do login, then we do one login without an online change. And here it's just going to say, I have an undeclared identifier because it's not put inside the PLC, so to speak. Instead, what we can do is you can log out, we can do an online change, and it's going to ask you, build and migrate system to current project state, yes. And then we can do one login, and then it's available there in the memory of the PLC. Other than that, I would say it feels and looks the same as the classical one, that you can stop application, you can do online force, and you can use a debugger, so you can step over, and all the stuff that you have. Basically, you can even see that it's almost identical with the buttons over here. I'm going to log out, and we're going to look at some of the new interesting things. So what I'm going to do now is I'm going to add a new function block. And as you can see, the editor for creating files here is completely different, because now we're not using the codices definition, so to speak, for creating function blocks, function block diagrams, ladder diagrams, etc. And we have a completely new one. We can choose the different functions, including, we can create global variables, interfaces, and everything else that you're used to from a PLC, from the classical PLC. One thing that's a little bit different is, of course, that here initially, the editor is obviously different. One thing that I found very interesting here is that, for example, if you create a function block, let's call it FB test, then we press OK, is this new create file editor here. So here you have a possibility to add your access modifier. You can add whether the function block has any extensions. This is if you inherit something. And the nice thing here, what I like, is that it clearly shows what it's going to look like in the actual code. So if I implement an interface here, for example, some interface, it's going to show it here in the editor. I think this is quite neat. And you can even add a descriptive comment, and it's going to show it here. So this function block is a test. So I like this one, actually. It's very, very neat. So let's create that function block. Here's another new thing with this editor. So first of all is that you can decide to choose whether you want to see the complete file in one, like in the whole editor, if you just want to see the complete file, or whether you want to have the traditional classical presentation, in the sense that it will show you both the declaration, so the var input, var output, local instance variable, and the implementation separately. So here, for example, if I was to create an instance variable, I can create an instance variable, be banana, bool, and I can set the banana to true. And what you can choose to do is to also let's get rid of this interface. We don't have it yet. We can choose to just show the complete file. So this is quite nice. We can work in either way. And this is maybe more what a classical, the classical IT. So this is maybe a little more what you might be used to if you're working with traditional IT development, where everything is just in one file, and you don't have a declaration part and an implementation part, and they're splitted by this split bar here. So I like that Beckhoff gives the options to do either or. And again, I want to stress this again, that now when we have created this file, it doesn't matter whether you show this in the splitted view or whether you show the complete file. The storage of the file is still here. If you go to FB test, it's still just one file, okay? So this is purely a selection of how you want the file to look like. Another difference is how you manage your code. So for example here, we can actually put everything in one file. So if we want to have an enumeration declaration, previously with the codices compiler and editor, you had to have the POUs and DOTs in separate files. For example, if I want to have an enumeration, I had to define it outside of the function block, and it had to be its own separate DOT. I can still do that here, so I can still do something like let's see here, enumeration. I can create my let's call it banana or fruit enumeration, and I can call it. Yeah, so you see here the editor is actually very nice, because I can work either here or in the editor here on the side. So I can make an apple, and it can be a banana. I can create my enumeration like this, so it's separate. But I can also create a definition directly in the function block file. Or it's actually not a function block, because the thing here is that we have a source code file. And we can mix and match function blocks and functions and everything, and enumerations in one file. You don't have to have separate file for this. Obviously, if you have been working with PLCs for a long time, this might feel like the natural thing to do, to just have separate files for this. But if you are a C programmer or doing a programmer from other classical traditional programming languages, then you might have always thought, why do I have to have separate files for all the different definitions? So here, for example, I can make a definition. Let's just take this fruit and I can put it here. So I'm going to call it, instead of fruit, I'm going to call it color and red, blue. I can have this here. I can have the definition in the same file as I have my function block. So in this case, I called this fb_test, but this could be, it doesn't have to be a file specific for this function block. This file could be called, something else than fb. It could be called my class. Right. And so if we go back here to complete file, I can instantiate this color here now. So I can create an instance of it, eColor, and I call it, it's a color. And this is totally fine. This is something, so we can build it. This is something that was not possible to do with PLC, with the traditional PLC. So I can instantiate an instance of this function block in my main program and execute it. So I'm executing the body of the function block. And this is totally fine and totally valid, which is, gives, so yeah, this is interesting. So what I'm actually doing is that I'm instantiating an instance of the function block fb_test, but it's residing in the file myclass.plc. So it doesn't have to be named the same as the file that I'm creating doesn't have to be named the same as the function block. It can be named anything, and it can contain anything as well. So this is a little bit different to what you might be used to with the codices. I must say that you don't have to do it this way. You can, of course, structure your file structure in the traditional way if that is what you prefer. That's totally fine. However, it does seem like the type declarations and everything are still global. That is, that even if I define this enumeration type in myclass.plc, I can still instantiate it in anywhere else. So if I go to the main program here and I create an instance of my color, this is confusing. I've set the keyboard to Swedish, but for some reason it's still German. I can't force this machine to use a Swedish keyboard. I tell it to use Swedish, but I still get German. And for some reason in Germany, they messed up. They messed up, because if I press Y, I get Z, and if I press Z, I get Y. Like, what's the problem? Why do you have to? The language is already hard as it is. It's like impossible to learn. I've been trying to learn it for ages, and I still can't speak proper German. And not just that, they also have to screw up the keyboard layout. So when I press Z, I get Y, and like, why? Why Germany? Why do you have to make life so hard? Where was I? When you create an instance of the color, so my color, I can still instantiate it here. So I can do what did I call it again? I didn't call it I just called it color. That works totally fine. See, that works. However, and I assume that all of these things, so I haven't read the ISC standard. This is, again, as I mentioned in the presentation, this is based on the 4th edition of the ISC standard. I assume that the standard allows doing these all kind of things. Maybe the way we've been taught to work with PLC code is because we've been working with the codices interpretation of what you're allowed and not allowed to do. Maybe now we're actually closer to the standard, or maybe we're further away from the standard. I have no idea, but I think this is very interesting. Of course, I would want to read the standard, but like with everything else in the world of industrial automation, it costs money if you want to have access to the standard. So nope, not going to happen for me. I should mention, however, that there's an additional thing here called namespaces. I haven't had time to look into it, but if there are namespaces and if they work similarly to how they do in other programming languages, I assume you could put these definitions in a separate namespace so you can do a little bit of grouping of how things should belong together. But namespaces is going to be a separate video. Okay, let's look at some additional nice features. So because Beckhoff have full control of the new development environment for the PLC part, they are actually able to do some quite nice things. And I'm going to show you one of those now. So if you go into our class here and we add a variable, just let's call it an counter, something, yeah, always the counter. And we increment it by 1. Like so, and we execute it. So we create an instance of our fb_test here in our program, and we execute it. So if I do an activate configuration of this, they have a very, very nice inline scope that I think is quite a good idea, actually. So what you can do is that you can log in, you can go to FB test here, so we see our counter is incremented, and you can right click here and you can not just show the value. So this is the typical layout of how it's working in the PLC Classic. If we go here, we can also do display trace. So it actually shows us like a mini scope over the values, which I think is quite neat. You can even show both, so you can get both the value here and the trace. I think this just shows, I don't know, when I see this, it just gives me this feeling like, well, I think of two things, first of all. The first thing I think of is that Beckhoff, before I came to SBS, because I wanted to see this, I came especially to SBS Messe to see this, I made the assumption that Beckhoff have announced PLC++, and, you know, they haven't been working on it so long because, you know, Siemens had released their Symmetric AX, Codesys had announced their Codesys Go, and there was all kinds of buzz around this, right? So I thought maybe Beckhoff now want to announce something to show that now we're also on this train. So I thought they just worked on this for a few months or something and made an announcement just so that they wouldn't be behind on the train, so to speak. But when I saw this, I immediately realized that they have actually been working on this for quite a while. I mean, what you've seen so far is only a tiny fraction of everything, but it's obvious that Beckhoff have been working on this for quite a while. Okay, so that's the first thing. The second thing, when I see this, is of course that I realize that if Beckhoff have been able to add this, you know, they have free hands to do many other things that I can't even imagine at this point in time. But I'm sure that there are going to be many additional good ideas of how we can extend and make this development environment much more usable and with better features. I mean, one thing, just looking at this, even in TwinCAT 4026 using the traditional PLC, the Codesys-based PLC editor, the online view is still, if you use dark mode, the online view is still not it's not dark. It's still light. And in here, they have obviously fixed it because they have full control of it. So I'm running dark mode now. That's my preferred way. I use dark mode everywhere, VS Code, here and any other editor. And here it's obviously working very well. So I think that's very nice. Okay, another feature that I think is very neat is a feature where you can add inline scopes, or I don't know whether that's the correct name, but let me demonstrate. So let's assume that we have our counter here in the function block FB test, and we want to show that from example the main program. So we want to show here when we do an online login the actual value of that while we're logged in. So what we can do here is we can add a comment anywhere, actually, for example here, and this is a comment. We want to show a value, and we can through this use through this keyword we can add the FB test dot n counter like so, and then we can log in and invalid access on protected variable encounter. Okay, so the variable is local. Another it's hidden, that is. I mean, it's a local instance variable, it's not public, so let's make it public. Another possibility now with the new PLC++. So we can take this one, make it var public counter, and let's just do an online login here and see. Okay, I guess we have to, let's just do a whole activate configuration here. Login. Here, see, so this is a comment we want to show a value. So we can show inline here while we're logged in the value of any arbitrary variable that we want to show. So very neat function. And as with everything else, you can show the trace here for those variables as well. So quite useful, I think. So I went there very quickly actually, but I don't know if you notice it. The variables are, if you declare a variable as local now, so you don't do it public, if you leave it like this, it is actually truly local with the Codesys variables. So Codesys variables, that's the wrong name. In the classic PLC compiler and editor, you could read local variables from the outside. So in the old one, you could actually access it in this way, fbtest.ncounter. Now it seems we can't do that anymore. So if I try to compile this, if I build, no, we get an error. But if I make it public, so this would work. Reading a variable would work. Let's just assign it to something else and blah blah int. So this would work with PLC++. Here we say, you see, invalid access on protected variable encounter. So that's neat. I always got a little annoyed at that with the old PLC classical one. So which means that I now have to go and change this one to var public for me to be able to access the local variable. Breaking the whole thing with an encapsulation of object-oriented programming, obviously, but we can do this. Oops. Let's try. Yeah, sorry. This is it's different types. So let's try again. Yeah, and that built. So that's a nice addition, that local variables are actually local variables. Another thing that's new here in PLC++ is something that Beckhoff called code snippets, which I think is very neat. So if you go to the complete file here, let's imagine I want to add a method to this class, or this file. So I could, of course, do it traditionally, just start to write method and my method, etc. But what I can do instead is I can write sn underscore, and then there's some code snippets, so some templates for a method. This is available for other things than just method. I'm going to show it with the example method. I find this very convenient because I can click here and I'll get just a template of, with var inputs and local variables here for the method, and I have to put a name. But I can also do method, so I can also do this sn underscore meth. And it says here, click or press enter to insert an editor, or control. Let's see here, we have a little problem with the size here, or control click. So we can do also control click, and then it shows us this editor instead. So this is super convenient if you don't want to remember exactly all the stuff you need to do in order for you to create a method. So here you can call it my method with a, let's say, private modifier. This is the return value, so it can be a string, and the script a comment. This is a method. Okay, and it creates a method with the default for you. So I think this is very convenient. Just one tiny thing I discovered is, of course, I accidentally put the method here outside of the function block, and you can do that with functions, so free functions you can do that with. However, with methods, they belong to, they have to belong to an instance of something, so an instance of a function block. So I need to move this over to inside the declaration of the method. So like so. Now it should hopefully compile. Let's build solution, and that builds. Okay, so I want to finish with showing how you can combine the traditional PLC part of TwinCAT with the new PLC++, and that you can actually run them in parallel with each other. So you can not, it's not that you have to choose between running PLC or PLC++. It's really an and. You can do both. And it gets even better. You can actually even exchange data between them two, just like you would traditionally do if you had two tasks or two programs in PLC++, or two separate virtual PLCs where you would just exchange the data between them. You can do that here in the very same way. So what I'm going to do is I'm going to create another PLC project here. And it's not going to be a PLC++. I'm going to create one that's called the standard PLC project. So this is the traditional codices-based one. And I'm going to call it PLC Classic. So here everything should be familiar to you for everyone that has been using TwinCAT. So here we have the classical one. I'm going to create an... Oh, so this is not dark mode now, but that's fine. I'm going to create a variable here. So we're going to do some data exchange between the two. So I'm going to say be hello PLC, or from PLC Classic to PLC++. I'm going to call that, let's see here. There we go. It's going to be a Boolean. And I'm going to receive a variable. So from PLC++ plus to PLC Classic. And that's going to come in. And I'm going to do the other way around in the PLC++ part. So I'm going to here in main create two variables. And I'm going to just invert this. So it's going to be from PLC Classic to PLC++. That's going to be an input. And here it's going to be an output. Right? And I'm not going to execute them in the code. I'm simply just going to do an online force in either end and write the variables so we can see that they're transferred between the two applications. So first of all, we do as usual that we do build our whole solution. And then we're going to get our instance variable here for the for the linking for the process data that go through the TMC file. And then you have them the same thing here. So this is the one. These are the ones for the PLC++, and these are the ones for the PLC Classic. So I'm gonna link the PLC++. So from PLC++ to PLC Classic, the output to the from PLC++ to PLC Classic. So I'm gonna link these two together. So I'm gonna click here. I'm gonna link them. Link here, and I'm gonna do the other way. It for the other way around as well. So I'll do that. And for the fun of it, I'm just going to create a variable here that just to show that this is actually executed here as well. Like so. So we can see that both of them are running. For the fun of it, let's just make an equivalent variable here. We have one already, so encounter. So we can see that both of them are running. So I'm going to build this now. So let's do an activate configuration of this guy. Restart. And now I'm actually running these two in parallel. I'm running the PLC++ one and the PLC Classic, and both of them have their each and one of them has its own task. So everything is just as usual, just like if you would be running two PLC Classic tasks in parallel. So everything else is equal. You can still do your affinity work, so you can assign your tasks to different cores, and you can set the different cycle times. You can set different priorities on them if you share tasks and everything. All of that stays equal. So I think what Beckhoff have done here is, of course, very nice, because if you transit to PLC++, then your normal workflow stays the same. So let's just look at this communication thing when exchanging data between them. And that's something that you can do already today with PLC Classic. If you have two PLC Classic tasks, you can exchange data between them. And that's something you can still do also with PLC++. So if I do unlogin here, that's the wrong one. If I do an unlogin here on the PLC, and then I'm going to open the Classic program, the one you're used to, and I'm going to put them side by side. So I'm going to do something like this. So we have both of them here. First of all, we can actually see that both of them are executed in parallel because they're running onto separate different tasks executed in parallel to each other. And we can see here that the online value are false for both because we haven't done any data exchange. So let me start with doing a data exchange from PLC++ to PLC Classic. If I do an online write here, if I set this to true and I write it, so note that I'm using the PLC++ toolbar here, not the PLC Classic, because right now I'm controlling the PLC++ part. So I'm going to do a write value here, and then we can see that the value to Classic went to true. So the transfer from PLC++ to PLC Classic works. If I do it the other way around, that I do an online write going from PLC Classic to PLC++, so an output from PLC Classic to an input in PLC++, then this is going to turn to true. So if I do an online write here, the other one turns to true. And I think this is extremely neat, and I think this just shows that Beckhoff have put a lot of effort into making sure that PLC++ should still have all the capabilities that you have in the traditional PLC, plus many, many, many other things, obviously. And what I think is great here is that, at this point in time, I will be able to choose whether I want to use PLC Classic or PLC++. And if I have a lot of code base written in the PLC Classic, I can continue using that, and I can do some newer parts only in the PLC++. And I mean, Beckhoff are going to provide a tool to convert all PLC Classic code to the PLC++, which I'm not going to talk about today. So that's a tool that's going to be available when they release PLC++. But for the people that are a little nervous, that is including me, this gives me a little bit of possibility to use my traditional PLC Classic code and play around and add just small fractions of the code into PLC++ to get a little bit of feeling about it, how it works, what the difference is. And I mean, one thing I haven't talked about here at all today, which is one of the features here, is that with the new combination of the new compiler at the new runtime, we get much, much more performance. So it's a factor of 1.5 times faster runtime performance with the new PLC++. So it really gives you an incentive to transfer your code to the new PLC++, because you're just going to get much more performance, which means that you're going to be able to run much more code, more complicated code in your existing controller, and or possibly to lower the performance class of the controller and run with something smaller and cheaper, which, it's not just about the cost of the hardware, it's also about the cost of the licenses, which is obviously something you always want to go down with. So I think that's great. Okay, I think I'm gonna have to start to round up here. I mean, there's a lot more stuff I would want to talk about. It's just that I don't want to make this initial video too long. Obviously, I'm gonna make more videos about PLC++, as you probably figured out. I think this is very exciting. I really look forward to start using this for my clients. I know already a couple of very good use cases where this PLC++ is going to give tremendous advantages, not only from the perspective of the development environment, but also of other things that we haven't discussed so much, like build pipelines and a command line interface. And I mean, there's other things I haven't talked about here that I will obviously have to talk in other videos, like, you know, namespaces, for example. How does namespaces work? We don't have that functionality in the PLC Classic, but it's something that we have in PLC++. We haven't measured the runtime performance. Beckhoff are mentioning 1.5 times factor. That's what it says on their website, at least. It would be interesting to see what the actual differences are in runtime's performance. So putting this on a real PLC, running a heavy application with PLC Classic and running an identical heavy application with PLC++, and measuring the runtime performance differences. One thing I haven't discussed is, of course, the new editor for the graphical programming languages. So again, I'm not a graphical programming languages guy, but Beckhoff have put in a significant effort into making an even better graphical programming languages experience for everyone that is using this, which is, in the end of the day, a big chunk of all people doing PLC programming, especially on the other side of the pool. Another thing we haven't talked about there is the command line interface tool. So that's something I'm not going to cover in this. For me personally, this is very important because one of the things I've always been annoyed at with Beckhoff and TwinCAT is when I'm going to build my pipelines and I'm going to build my automation pipelines that are running my tests, that are building my libraries. All of this builds on the TwinCAT automation interface, which requires you to have a full instance of Visual Studio, and that's very slow. So hopefully the command line interface is gonna give me some of that. And there's many other things here. I mean, there's many more features here in the editor that I haven't showed you. I mean, there's things like here, multi-line. Look, show me here. Look what I can do. If I hold down Control, I can do like this. No, I mean, there's just many hidden quirks here and there I discovered that are quite neat, and that, yeah, I'm simply not going to be able to show you at this video, but I will make many more videos. There's also many questions that are popping up in my head while I've been playing around and working with this. One question here is licensing. What is the licensing going to look here from Beckhoff? Are they going to charge you an additional fee for PLC++? Is it going to be included in the normal fee for the runtime licensing of PLC, right? Because today we have the license TC1200, which includes IO, ADS, and the PLC Classic runtime, so to speak. How is this gonna work? I mean, I have my guesses, of course. I mean, if they now promise higher performance, and now people start to buy lower performance PLC because of this, you know, Beckhoff are gonna start losing money because of that. Maybe they want to charge you for an additional fee for the PLC++ runtime. No idea what they're gonna do. So this is, of course, interesting as well. Another question is, you know, how does the command line interface actually gonna be working, and how much will I be able to do there compared to what I'm doing through the TwinCAT automation interface today? And yeah, maybe you have more questions. Maybe there are some things that you would want to know. So I would really appreciate it if you could write your comments and thoughts in the comments here below, because I could take those questions and maybe ask them to Beckhoff. Maybe Beckhoff are going to read the comments. Also, if you have any other thoughts about what you've seen, I would be very interested in if you could share those with me. So that's it for this video. If you haven't already, please subscribe to this channel. And until next time, happy coding.